So last time we talked about simplifying square roots just with numbers. Like, for example, simplifying the square root of 16, we know is 4. But simplifying the square root of 75, you need to break that down into your perfect squares. And remember, it does help to have all your perfect squares listed out. And I know that the perfect square that goes into 75 is 25. So I have the square root of 25, and 25 times 3 gets me 75. And then when I simplify this, the square root of 25 is 5, and I can't simplify the square root of 3, so I simplify it like that. And then with the cube roots, it's the same idea. Your cube root of, for example, 16, the perfect cube root that goes into that is 8, and then 8 times 2 is 16. Simplify that, you get 2 cube roots of 2. So remembering that, we're going to go ahead and move on to square roots with variables. So this is going to seem a little confusing at first, but with practice, it becomes really easy. So, for example, given the square root of a to the mth power, if m is a multiple of 2, you're going to use the rule where you take your variable m and divide it by 2. So whatever your new exponent is, when you have your square root of a to the m, your simplified version is a to the whatever m is divided by 2. If it's not a multiple of 2, then you're going to break it up. So you're going to take your m value. So, for example, if your m is 5, okay, so if you have a to the, I'm not going to use 5, that's number 3. We'll do it down here. So if you have n to the 5th, you're going to go ahead and break that apart. So I'm going to make sure I have something that is divisible by 2, and then whatever's extra is going to go on the right side. So I know that I can subtract 1 from this to get 4, because 4 is divisible by 2. So I'm going to do the square root of n to the 4th times the square root of n. N to the 4th, I can divide 4 by 2, and that is n squared. And then I'm just going to bring down the square root of n. Okay, so that's all we're doing here. It's not too difficult with practice. So for the first one, I have x squared. 2 is divisible by 2. 2 divided by 2 is 1. So this, your answer is just x to the first power, or just x. For number 2, you're going to go ahead and make sure you're doing the square root of the coefficient first, which is where the stuff from last time comes into play. So we're going to do the square root of the coefficient first, and then do the square root of the variable. So the square root of 9, I know is 3. That's a perfect square. If I write them all out, and when I get more space, I'll go down to 100. But I know that the square root of 9 is 3. And then 10 is divisible by 2. 10 divided by 2 is 5. So when I simplify it, I get this. Okay, so at any point as we're going, if you want to go ahead and try the problem first, press pause, and then watch the answer. That's totally fine. I'm not going to specify when you need to do that. But please feel free to pause and go and practice these as you go. Okay, so now we're going to go ahead and do this one. You need to go ahead and do the square root of 40 first, and 40 is not a perfect square. So we need to figure out which numbers go into 40 in order to simplify this. And I know the biggest perfect square that goes into 40 is 4. So I'm going to have 2 different sets of radicals, okay? So under the left radical is where I'm putting all my stuff that I know I can find this perfect square, the square root of. Anything extra goes under the right side. So I know that 4 is a perfect square, so I'm going to put that over here. And 4 times 10 gets me 40. So my 10 is going to go over here. Now I have a to the 19th. 19 is not a multiple of 2. So I need to go ahead and take one away from that to make it a to the 18th, and then put my extra a over here. So now I can go ahead and find the square root of the left side. So I'm doing the square root of 4, which is 2, and the square root of a to the 18th power, which means I'm going to do 18 divided by 2. 18 divided by 2 is 9. And then I can't do anything with this stuff, so I'm going to rewrite it here. Now just double check. Make sure that this is as simplified as you can go before you submit your final answer. Okay, for number 5, I'm going to do my 2 radicals again. So my first part is 25. I know 25 is a perfect square, so it's going to go on the left side. I don't need to write the factors. 25 is a perfect square, so we're just going to put it there. X to the 6th, I know that 6 is divisible by 2, so I'm going to go ahead and put the whole thing right here. Now y to the 13th, 13 is not divisible by 2. So I'm going to take my y1, put y to the 12th, and then bring my extra y here. So now I can go ahead and simplify. The square root of 25 I know is 5. 6 divided by 2 is 3. 12 divided by 2 is 6. And then I'm going to bring down my extra square root of y. For number 6, we don't have a coefficient this time, so we're good. We just need our variables. So I'm going to go ahead and do my 2 radicals. That's step 1. Always draw your radicals. Okay, and then I have 15. 15 is not divisible by 2, so I'm going to subtract 1, put 14 here, and put the other p there. 9 is not divisible by 2, so I'm going to put my 8 here and my extra q over here. And r, there's only one r there, so I'm going to put the r on the right because I can't do anything with it. So now I can go ahead and divide these exponents by 2. So 14 divided by 2 is 7. 8 divided by 2 is 4. And then I'm going to bring down PQR under my radical. So my final answer is p to the 7th, q to the 4th, times the square root of PQR. For number 7, I have 63. And I have to think about my factors. What's the biggest perfect square that goes into 63? I know the biggest perfect square that goes into 63 is 9. So I'm going to do my square roots. And I know 9 times 7 is 63. So I'm going to go ahead and write that. And then I have b squared. And 2 is divisible by 2. So I'm going to go ahead and put that on the left. So now I'm done. I can go ahead and simplify. The square root of 9 is 3. The 2 divided by 2 is 1. And then the square root of 7. Right, so number 8, 27 is not a perfect square, but I do know that 9 goes into that one as well. So I'm going to go ahead and write out my radicals, put 9. 9 times 3 is 27. And then n to the 3rd, I know the 3 is not divisible by 2, so I have to subtract 1. And I put the extra n over there. So now I can go ahead and do my square roots. The square root of 9 is 3. 2 divided by 2 is 1. And then I'm just going to bring down my square root of 3n. So I have 3n square roots of 3n. Right, for number 9. So now this is a little different. We have that coefficient on the outside, that number. So what we're going to do is we're going to do our same 2 radicals, but just like before, whatever's on the outside is what you're multiplying by. So I'm going to have 8 times whatever I simplify, then the square root of whatever's extra. Okay, so I'm going to focus on my 320, x, y to the 4th. So 320, I know that that is not a perfect square, but I do know that I can get 64 into 320. And you can check that by going through your calculator and taking 320 divided by, I would start at the bigger perfect squares and work your way down, just to make sure that you are getting the biggest perfect square. So 320 divided by 64 is going to get you an answer of 5. So 64 times 5 is 320. And now I have my exponents. I have an x with just a 1, and since it's just 1, it goes on the right side. For the y, I have y to the 4th. 4 is divisible by 2, so that's going to go on the left. Okay, and now I can go ahead and simplify. I'm going to bring down my 8 times, and then the square root of 64 is 8. 4 divided by 2 is 2. Bring down my square roots of 5x. And now I can multiply my coefficients. 8 times 8 is 64. Y squared, square roots of 5x. All right, so same thing for 10. The negative 2 is the exact same process, it's just a negative. So I'm going to bring down my negative 2. Do my square roots. Okay, for 180. I know that the biggest perfect square that goes into that is 36. And 36 times 5 will get me 180. Okay, and then I have u squared. That is divisible by 2, so it goes here. And there's just one v, so that goes on the right. So now I can go ahead and simplify. The square root of 36 is 6. 2 divided by 2 is 1. And then bring down my square root, 5v. Okay, so now I can go ahead and multiply my numbers. Negative 2 times 6 is negative 12. Bring down the u. Bring down the square roots of 5v. All right, so number 11, same idea. Just a lot more numbers underneath there. So I've got the square roots and the square root. So 128 is not a perfect square, but if you test them out, you can find that 64 times 2 will get you 128. So 64 times 2. And now I can go ahead and do my variables. So 5 is not divisible by 2, so I'm going to put 4 here and put the extra p over here. 2 is divisible by 2, so I can go ahead and put that here. And 18 is divisible by 2, so I'll put that here. So now I can go ahead and simplify. The square root of 64 is 8. 4 divided by 2 is 2. 2 divided by 2 is 1. And 18 divided by 2 is 9. And then bring down the square roots of 2p. All right, and the last one, same idea. There's just a lot of variables under there, but it's okay. You can do it. So we're going to do negative 5 times our 2 radicals. Now this one, we have 144. 144 is a perfect square, so I'm just going to go ahead and write that right here. All right, x to the 16th. 16 is even, it is divisible by 2, so I'm going to put it. 10 is divisible by 2. And 7 is not, so I'm going to put 6 and then an extra. So 144, the square root of that is 12. 16 divided by 2 is 8. 10 divided by 2, that's a y, sorry, is 5. And 6 divided by 2 is 3. Square roots of z. Negative 5 times 12 is negative 60. X to the 8th, y to the 5th, z to the 3rd. Square roots of z. Okay, so now that you kind of have an idea on how to do that, we're going to flip to the back and do cube roots. So cube roots, it's the same process. Just with square roots, we use 2 because our index is 2, even though it's not listed, our index is 2. For these ones, our index is 3. So since our index is 3, we need to go ahead and use 3 as the number we divide by this time. So our rule now is a is m divided by 3. So we're going to take whatever our exponent is and divide by 3 because it's a cube root. Now, if it's not a multiple of 3, you're going to break it apart so it is. So, for example, at the top, I'm going to do this, okay, a to the 5th. So we have the a to the 5th. So I know that I can split that up because when I multiply my variables and my exponents, that means I add them, right? So if I'm trying to separate this, I can just go ahead and subtract. So I'm either going to subtract 1 or I'm going to subtract 2 in order to get the number to be a multiple of 3. In this case, I need to subtract 2 because 4 is not a multiple of 3, but 3 is. So I'm going to have the cube root of a cubed times the cube root of a squared. Okay? So that's kind of what we're looking for. We're just looking to subtract either 1 or 2 instead of last time it was just 1. This time it's 1 or 2 in order to get to our multiple of 3. So for the first one, we have the cube root of x cubed. Now 3 is a multiple of 3. Okay, so 3 divided by 3 is 1. So our answer is x. Now, I'm going to go ahead and write out the perfect cubes for you. This is not something that I am expecting you to memorize because you can use your calculator to get this list. What I am expecting is for you to have this list written out. It will make your life much easier if you always have this list written out. And remember, for cube roots, we can have positive and negative answers. Okay, with square roots, we only have positive answers. But for cube roots, you can also have the negative, which is why I'm doing this positive and negative sign with my numbers. So just copy this down so you have this on your paper. All right, so you have that to reference as we're working. So for number 14, we have the cube root of 64 times m to the 9th power. Now 64, I can see on my list right here, it is a perfect cube. So I don't need to split this up most likely because 9 is also divisible by 3. So I don't need to do my two radicals for this one. The cube root of 64 is a positive 4. And then 9 divided by 3 is 3. So our answer is 4m to the 3rd. So now what we're going to do is we're going to go ahead and solve these ones. Now, I don't have a coefficient here, so that means I only need to do my addition or subtraction. I have p to the 7th here, and I know that I need to subtract something from it to make it a multiple of 3. I know that 6 is a multiple of 3, and 7 is only one more than that. So I'm going to do p to the 6th, and then p. 6 divided by 3 is 2, and then cube roots of p. Please, 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 please make sure if you're doing these cube roots that you are putting that little 3 as your index. If you forget the 3, then it becomes a square root and it becomes wrong. Okay, so make sure if you're working with cube roots, you keep the 3 as the index. For number 16, this is another one where we have that multiplication out front. So I have negative 3 times, and then I can break up my radicals. Okay, so 40, I know that is not one of these perfect cubes. However, I know that 8 does go into 40 because 8 times 5 is 40. So I'm going to go ahead and put 8, and I'm going to put 5. And then I have w to the 16th power. I know 16 is not a multiple, but 15 is. So I'm going to go ahead and subtract 1. And then I can go ahead and simplify. So the cube root of 8 is 2. And 15 divided by 3 is 5. Times cube roots of 5w. Okay, so now I can do negative 3 times 2 to get 6. W to the 5th cube roots of 5w. Okay, so same process as before, but this time we're using the cubes instead of the squares. So for number 17, I have 512 under here, and I know that that is a perfect cube, but I can see that these other ones aren't perfect cube numbers, or aren't multiples of 3. So I am going to go ahead and put my 2 radicals. Okay, so 512, I know that that is a perfect cube. It's on my list. So I'm going to write it down. And then I have x to the first, and I know that that is not a multiple of 3, and there's no way I can make that a multiple of 3 with subtraction. So I'm going to go ahead and put that on the right. But y to the 10th, I know that 9 is a multiple of 3. So I'll do y to the 9th, and then the extra one goes over here. So now I can go ahead and solve this, and the cube root of 512 is 8. And then 9 divided by 3 is 3. Then bring over my cube root of x, y. Okay, so for number 18, same as above, we need to go ahead and multiply first. And then we're going to write out our roots. Don't forget that 3. Okay, so I have negative 250. Now, when you have a negative under the radical, you want to keep the perfect square number that you're putting on the left side. You want that one to be the negative. You don't want a negative underneath your simplified radical. So I'm going to do whatever my negative number is going to be the first number, and my positive number is going to be the second. So I know that 125 times 2 gets me to 250. But since this is negative, I'm going to use a negative 125 and then a positive 2. Okay, so then I'm going to go ahead and figure out how my variables go. A to the third, 3 is divisible by 3, so I'm going to go ahead and just bring that down. And then to the fourth, that's not, but I know b to the third is. And then put my extra b right here. And go ahead and simplify. The cube root of negative 125 is negative 5, and you can find that out by pressing math and then 4 on your calculator and typing in negative 125 under the radical, and it'll simplify it for you. 3 divided by 3 is 1, 3 divided by 3 is 1. All right, so then 2 times negative 5 is negative 10 AB, and then cube roots of 2b. All right, for 19, I've got the negative 32 under there, and I know that a negative 8 times something is going to get me to negative 32, so I'm going to use negative 8. And negative 8 times 4 is 32. And then I have p to the 17th. The multiples of 3 that I know, if you need help, you can write those out too. 9, 10, 12, 15, 18, 21, 24. Okay, so you can write the multiples too, so that helps you. So 17 is in between here. So 15 is the closest one I have. So I'm going to do p to the 15th. And there's 2 extras, so I'm going to put them over here. And then q to the 8th, the closest one I have is 6. And then put the 2 extras over here. Okay, and then I can go ahead and simplify. Negative 8, the cube root of negative 8 is negative 2. 15 divided by 3 is 5. And I'm sorry, why did I write 8? That should be a 6. And then 6 divided by 3 is 2. And then just bring down the rest. All right, so for number 20, we're going to go ahead and put our 3 first and do the cube root. Okay, 128 is not a perfect cube, but I do know 64 times 2 will get me to that. And 64 is a perfect cube. And then I have the 9 that is a multiple, as is 21. So I'm just going to put both of those under the first radical. Okay, and then 3 times the cube root of 64 is equal to 4. 9 divided by 3 is 3. 21 divided by 3 is 7. And then bring down the cube root of 2. 3 times 4 is 12. A to the cubed, b to the 7th. Cube roots of 2. All right, so we have 2 more. The same process, negative 48, the cube roots that go into that's going to be negative 8. And negative 8 times 6 will get me to 48. And then x is not divisible by 3. 9 is divisible by 3. And then this 5, I can subtract 2 from it to make it divisible by 3. All right, so then I can go ahead and simplify, and I have this is going to get me to negative 2. 9 divided by 3 is 3. 3 divided by 3 is 1. Bring down the rest. All right, and then 7 times -2 is -14. Y cubed z, and then cube roots of 6x z squared. So for 22, we're going to go ahead and do the same thing. I know that 64 will go into this, and I can check that by using my calculator. And I know that 64 times 3 will get me to 192. 8 is not divisible by 3, but 6 is. So bring the 2 extra over here. 2, I can't get that to work. And 18 is divisible, so I'm going to keep that over here. And go ahead and simplify. And I get 4r squared t to the 6th cube roots of 3r squared s squared. So for the summary, what I want you to go ahead and write is we're just going to write the steps basically that we're following to do this. So the first thing you want to do is list your perfect squares / cubes. Okay, so list all of those out. And then number 2, you're going to want to simplify your coefficients. Sorry, I can't spell. Coefficients. So make sure you're writing both radicals out too. After you simplify the coefficients, you want to simplify the variable exponents. Variables. Yeah. And then you're going to simplify that cube or square root of whatever your left radical is. The right one should have all your extras and you won't do anything to that. But the left side is what you need to make sure you're simplifying. And of course, if you do have extras that you think can be simplified under that right side, you're going to want to keep going and make sure it is as simplified as possible. Do not stop until it is totally simplified.